Hi students, you are starting Module 3 of your Lizard Evolution Virtual Lab, and there's some math in here that sounds a little scary, but I'm going to walk you through it and try to get you confident with what exactly you're trying to find and how to find it. Let's use, for example, let's say that I gave my students a test, but I only gave it to 5 of you. And I wanted to know what the average test score was. Well, then I would find the mean. The average and the mean. They mean the same thing. And that's useful information. I can kind of figure out where the middle ground is for my students' test scores. Then I could calculate something called the standard deviation, or the SD, and this basically tells me how far from average does my sample get. Did all my students score right at 80%? Did I have a bunch score at 70% and then one scored at 100%? The standard deviation kind of tells me how far from average. What's the range? What's the spread of my student scores? Then the standard error, SEM, that's useful because if I only had tested 5 students, but I kind of wanted to make a good estimate of what maybe 100 students would score on the same biology test, assuming they all had me for the same teacher, and I wanted to find the standard error, I'm asking myself, if I applied this average that I just calculated to a larger sample size, what could I expect? How close to that average do I think a larger sample size of students would get? And then that brings us to the last one, a confidence interval. A 95% CI essentially says I am 95% certain that in a larger sample size, let's say I tested 1,000 students, the average would fall within how many of my sample average? Within 5 points of that average? Within 10 points of the average? Am I 95% certain that in that larger sample size the average would fall within 1 point of my sample's average? That would be really good. So the smaller number that you get here for your CI, the better that it is, actually. It means you're super confident in the number. You've really narrowed down what you think the average is going to be. Okay, so now that you kind of know what those terms mean, let's walk through how to find each of them. And I'm just going to use an example of test scores again. If I had 4 students, and here were their scores on the test, so here's the students, here's their scores over here. I'm going to just say that X is the individual score. So for student 1, it's 70%. That's their X. For student 2, it's 80%. That's their X. Get the idea? Yeah. Okay. So then you're also going to see this letter N, and that means number of students. So I have 4 students. All right? To find the mean or the average, in this particular module, they use an X with a little line over it to represent the mean or the average. Okay, so it kind of looks like this X up here, but that's just an individual score. This one is the mean or the average. So I think you guys know how to find averages. You add all these numbers together and divide by however many there are, in this case 4. Okay, so I added those numbers together, divided by 4, and the mean for this data, my mean test score, my average test score was 85%. Yeah? I'm just going to leave the percent off there, but it's just 85. That's how you find the average. No big deal, right? Okay, but the next thing I want to know is how close were my other students, all my students, to that 85%? Because I had one that scored at 70 and one that scored at 100. So how can I express sort of how spread out the scores were? That's where standard deviation comes in, SD. So to find SD, here's the big scary equation. And you can also find these equations in the calculations part of your Lizard Evolution Virtual Lab. So click on that tab, and it has a good description of it. You'll take the square root of, and then there's this funny E thing. That means the sum of. Then you're going to take the individual score minus the average, or the mean that you just found, and you're going to square that. So you're going to do this part first right here, and then you're going to add all those numbers up, and then you're going to divide by the number of samples minus 1, and then you're going to take the square root of that whole thing. Oh my goodness. Okay, so let's walk through it. It's easier to just go through it. Here we have student 1, 2, 3, 4. Here are their scores right here. Okay, so the first thing I want to do is I want to find this individual score minus the mean. So the individual score of student 1 is 70, so I just put that right here. That's your X. Okay, the mean that we calculated was 85. So I take 70 minus 85, and that gives me a negative 15. Okay, so I did that for my first student. I have to do the same thing for the second student now. So student number 2 scored an 80%, so I take the 80% minus the average, and that gives me a negative 5. And I do that for student 3, and I do that for student 4. Okay, so all that I've done is I've taken X minus the average for each one of these, and I get these numbers at the end. Now what I'm going to do is I'm going to take those and I'm going to square them. So for each one of these, the number that I got, I just hit the square button on my calculator. So for this one, 15 squared is 225. Excuse me, negative 15 squared is 225. Negative 5 is 25. 5 squared is 25. 15 squared is 225. Phew. All right, so we've done this part up here. Now we've taken x minus the average, and we've squared it for each one of those. Now this big weird looking E right there means add all those together. So I'm going to take 225 plus 25 plus 25 plus 225, and if my math is correct, I get 500. Okay? So that's the number that I'm going to end up putting up here on top of this line for that whole thing. Phew. All right. So I take 500 and then I divide by 3. Where'd you get 3? Well, because n is my number of students, and I have to take 1 off there. Why? Quit asking questions. Just do it. Okay, so 500 divided by 3, and when I did that, I got 167.3, and then I got to take the square root of that. So my standard deviation is almost 13. It's 12.9. It might be 12.9 something, something, something. I just rounded it to the nearest 10th spot because I'm the teacher and I get to do whatever I want. Okay, so my standard deviation is 12.9. What does that mean? That means my average score is 85, but I recognize that within that average score of 85, I could have a student who's about 13 points ahead of that on a score. So it'd be like a 98, or about 13 points lower than that average of 85. So that's a pretty big number. It is. And that's okay. That's how you find standard deviation. It's just a number like that. Okay? Okay, and I am going to give you a table like this one up here when you go to calculate your lizard scores, just because I think it's going to be easier than you just writing out a bunch of weird numbers on a piece of paper and getting lost. There's standard deviation. All right, so next what I need to do is I need to find something. Let me get to the right page here. Hang on, bear with me. Okay, I found my page. So now we're going to calculate the SEM, standard error. And what you're going to do is take your standard deviation, your SD that you just calculated, and you're going to divide by the square root of however many samples you have. So my standard deviation was 12.9, and I have a total of 4 samples, or 4 student test scores that I looked at. Okay, so the square root of 4 is 2, so I put that down here. So I'm going to take 12.9 divided by 2, and when I do that, I get about 6.5. And remember what that standard error of measurement tells us. It just says, okay, if we tested more students, if I took 25 student test scores, or 100, or whatever my test scores were, it basically gives me an idea of how that average would relate to the rest of, to the average that I found. Okay, so that is what my standard error of measurement is. Okay, so then I want to express how confident I am in my numbers. In order to find the 95% confidence interval, what this lab is asking you to do is take 2 times your standard error of measurement, that number you just came up with. And it's a little more complicated than that, but they're trying to make the math a little bit easier here. So you take 2 times 6.5, and that gives us about 13. So what exactly does that mean? That means that if I were to test 25 students or 1,000 students or way more students than what I had rather than just 4, I am 95% confident that the average of all those students that I tested would fall within 13 percentage points of my average. Remember, my average for the 4 students was 85. So I'm 95% certain that the average for a way bigger population of students would fall within 13 percentage points of that. And that's a pretty big number. Okay, if I had gotten a lower number here, I could, that's a pretty spot-on measurement. So as a general rule, the more samples that you have, if I had tested more students in the beginning, then this number right here would be a little bit lower. So when you go to test your lizards, you're only going to be testing or measuring about 10 lizards, so you'll probably get a kind of a big number here for your 95% confidence interval. But do the math, see what you get, and I hope that this helped.